Moriah Central School Board of Education for allowing the town to hold this informational meeting here this evening. Now, the reason for this meeting is for just that purpose, to offer information on the proposed Moriah Hydro Project, and after Mr. Besha's presentation, we'll have a follow-up with questions. Now, this project has been ongoing since around 1990, I believe. In fact, when the project started, my hair was black and Mr. Besha had hair. When I first spoke to Jim regarding the idea of this, an underground hydro project, I mean, I got to be very frank, I thought he was nuts. You know, I couldn't even begin to understand the concept of using abandoned mines to generate electricity. Well, since that time, that was so many years ago, that dream that he has held on to and spent a lot of money on has now transformed into a project that may in fact become a reality. Just recently, the Moriah Hydro Corporation filed their final permit with the Federal Energy Regulatory Commission, and I understand that's what we're waiting on for now, on that application. Back in 2006, there was a public hearing with regards to the application that was held at the Mineville VFW. I believe that was required by the Adirondack Park Agency and the Department of Environmental Conservation. So that process has already been gone through. Now, I, like you, have many questions regarding this project. And as town supervisor, the first and foremost being, you know, what the impact will be on this community, both in regards to quality of life, environmental concerns, and also financial impacts. The benefits that our town and school would receive would be substantial, both in improvements to our infrastructure, recreational facilities at Lynn Field. The town of Moriah would also benefit from a new highway garage, which is a building that is desperately needed. The building that we have is over 50 years old. We can't even insulate it because of the snow load would collapse the roof because there's not enough pitch on it. And of course, this community, both the town and school, would see a substantial increase in our tax base, which would mean lower taxes for you if you live in Moriah and Moriah School District. Not going to get into projecting any numbers this evening. Way too early for that, but I will say that it would be substantial. The plan at this time is that the town of Moriah would either sell or lease, probably lease, a portion of the surface that's across from the highway garage that is actually owned by the people of the town of Moriah. The town of Moriah. And I give credit to former supervisor Ray Slattery, who had enough foresight at that time to purchase that piece of property from Republic Steel. We purchased it primarily for the use of the tailings, but not, you know, knowing that something like this would come along. But, so there shouldn't be any problems in regards to ingress and egress from the surface because it'll all be on town property. I'm sure that Mr. Besha will get into a lot of those details later on. The one thing that really excites me about this project, and I've seen a lot of projects come to fruition, I've seen a lot of projects fail. The ones that usually fail are the ones that have government dollars involved. This project here is not dependent upon any government dollars whatsoever. It's not dependent upon federal grants, it's not dependent upon state grants, it's not dependent upon any type of government loans. It'll all be through private investment. And I think history will show those are the projects that usually succeed. At this time, I'd like to introduce Mr. Besha. First, I want to read his bio. Jim Sr. is a professional engineer and is president and owner of Albany Engineering Corporation in Albany, New York. He earned his A.B. in Sociology and Bachelor of Science in Industrial and Systems Engineering from Syracuse University. He is a licensed professional engineer in New York and 8 other states. Albany Engineering Corporation plans, develops, designs, builds, rehabilitates, operates, and maintains numerous hydroelectric generation and water resource projects in the capital region and beyond. In addition to work for both municipal and private clients, Albany Engineering currently owns 2 hydroelectric facilities and has several other hydroelectric projects under development. Mr. Besha is responsible for all aspects of project development, design, project manager, and project management for Albany Engineering Corporation's consulting activities, as well as for projects the firm undertakes on its own behalf. He is also responsible for the administrative and financial management of Albany Engineering Corporation. Mr. Besha is an active member of numerous professional organizations, including the American Society of Civil Engineering, the American Society of Mechanical Engineering, the National Society of Professional Engineering. And with that, at this time, I'd like to turn it over to our guest, Jim Besha.
First of all, I'm going to mention the remote clicker doesn't work from down here. So when I go to change these slides, I'm going to be saying Steve. So if anyone else here is named Steve, don't answer back. Okay? There's also a few slides out of order for some reason, a few PowerPoints out of order. We'll deal with that as we go through. We're here tonight to talk about the Mineville, what we call the Mineville Pump Storage Project. We've also called it the Northern Pump Storage Project. We call it various things. I'll explain a little bit later what's involved and when it started and some of the history and some of the technical specifics as well. But first I thought I'd explain a little bit about hydro. I always start these discussions off by what is hydroelectric. People have a concept, but I try to bring it down to the basics so we know where we're starting. Steve? There we go. Anybody remember Richard Scarry's book? You read it to your kids? And this is Richard Scarry's book about hydropower. And basically it's very simple. Water is impounded in a river, goes through a turbine, spins the turbine, makes electricity, goes back out to the ocean, comes back up as rain, and that's how hydro works. Very simple. Hydro 101. Don't try this at home, however. Pump storage, however, is a little bit different. Next slide, Steve. What we're talking about tonight is pump storage. It uses hydroelectric techniques, but it's used to store electricity, store energy. When we use electricity in our everyday lives, turning on a light, generally that power is made, the instant we use it, it's being made somewhere else. There's not a big ability to store power. There's really only one common way of storing energy, and that's pump storage. People talk about batteries and those kinds of things. That's coming into being a little bit, but for the last 100 years, the only way of storing power, and we don't store very much power, is pump storage using hydropower. And the way that works is pretty simple. You have water in an upper reservoir, and in the daytime you take water from a lower reservoir, pump it up the hill to an upper reservoir, and then generally at nighttime you take that water backwards and run it back through the turbine and generate electricity. It's not perpetual motion. You don't get the amount of energy in that out that you put in, and there's some inefficiencies, but it's the only way of really storing significant amounts of electricity in a large grid system. In New York State, there are 2 pump storage facilities, one in Glen, Gilboa, in Scary County, owned by the New York Power Authority, and one in Lewiston, out in Niagara County, owned again by the New York Power Authority. And those pump storage facilities are primarily used to help the New York Power Authority supply power to New York City. They have very little to do with what's going on upstate. Big surprise, huh? This is the concept of pump storage. Normally the way it works is that you, next slide. U.S. has about 20 gigawatts, that's a lot of power of pump storage. There's only about 40 pump storage facilities in the entire United States. There's more in Europe, a little more common in Europe. Pump storage is common. As I said, there's about 40 of them. It's used somewhat. Not a lot of our power is stored, but it is stored by pump storage. Partially underground pump storage is less common. Sometimes the lower reservoir, or the upper reservoir, I should say, will be partially underground. Projects that are totally underground, like the Mineville Pump Storage Project, are not common at all. Someone asked me earlier, I think there's one in Germany and Europe, that's both upper and lower reservoirs are underground, but it's not common in the United States. That's just an historical fact. We're going to be talking about this project, and this is sort of a bad map, but you can, the outline of the mine, which, anyone here, no one here old enough, I think, to have worked in the mine. Anyone here work in the mine? Did you? Really? Fantastic. We'll talk to you later. Most of you know there's a mine somewhere underground up in the Mineville-Witherbee area. The outline of the extent of the mine is here. It's a very large extent, extends over maybe a half a mile or a mile. It's very deep underground. It extends from near the surface to almost 5,000 feet underground. We'll explain a little bit later what that means. Kind of people have an impression of a mine being a big cavern underground. It's not exactly that. The mining activities in the Mineville mine started about 1770 in this area, a long time ago. Some of the cannonballs of the Revolution were supposedly mined or built with iron, came from this area. And it extended until Republic Steel closed the mine in about late 70s, long period of time. I want to mention at this point two things, or thank two people. And one, posthumously, Patrick Farrell was the engineer of the mine for many, many years. He passed away some years ago. When we started this project years ago, Pat was an invaluable resource. A lot of his records, which are at the Museum of Blue Mountain Lake and down here at the History Center, came from Pat, and a lot of the things in our files, things that Pat shared with us many years ago. Also want to recognize Tom Scozzafava. Tom calls me about every week, if not more frequently. He's been an advocate for this project going way back when, and I'll explain in a second how the project started and how we got to where we are today, many, many years later. See? Back up 1 second, surface ownership. The surface area of where the entry to this facility is going to be is on Town of Moriah property. There are other issues concerning ownership. I mentioned this up front because people have questions. There is underground voids, tunnels and things that were built years ago that are full of water now. They've been capped over many, many years ago by Rome Pulling Company, or Republic Steel, I'm sorry. And then that property was bought by Rome Pulling, which is now Solvay Corporation. So there's a question, sort of, who owns the holes underground and who owns the water that's in those holes. There's another issue regarding the mineral rights. The minerals were essentially taken out of the ground many years ago by Republic Steel. They took the iron ore out, they extracted the iron ore and sold it. What was left is rock, tailings piles. You see them up here. If there's any more minerals left under there, probably not very many, but they're not owned by Solvay, we understand. They're owned by a company owned by K. Stafford. There's some questions here how these two things react to each other. Who owns the whole, who owns the minerals? We don't know the answers to those right now. We'll be figuring that out as this thing progresses. The license, however, will be owned by Albany Engineering through a subsidiary Moriah Hydro. Hydroelectric projects are federally regulated. The federal government, the Federal Energy Regulatory Commission, which was established many years ago as part of the Federal Power Act of 1920, regulates all hydroelectric in the United States. And what that means is, kind of bluntly, you get a federal license and you don't get local permits and local or state permits, with a few exceptions. So we've been working with FERC for many, many years, Federal Energy Regulatory Commission, we finally fondly call them FERC, to get a license on this project. A license is granted for a period of time, usually 50 years, and it gives us the right, as a company, to develop that project for hydroelectric and acquire whatever property is necessary to do that in the public interest. We essentially are acting as an agent of the government, as it were, although we're private, and it's a private proposition. Albany Engineering Corporation is my company. We were founded in 1924. I wasn't there when it was founded. I came along some years later. It's been around a long time, the company. It's an New York State Engineering Corporation. There's not too many of them. We specialize in hydroelectric projects, design, development, ownership, operation, maintenance. We do it all from soup to nuts. And that's all we do is hydroelectric. We've done projects from Seattle to Maine, northern Canada to Guatemala. The projects we work on the last 20 years, however, are pretty much in New York State, pretty much within a 2-hour radius of Albany. We stopped traveling some years ago, and there's plenty of opportunity around here, such as this project. The project that we're going to talk about tonight, Mineville Pump Storage, Mineville Energy Storage, however you want to call it, was started in 1990, believe it or not. And it was based upon some experience we had with other projects we were looking at for other developers in California and Hawaii, where they were looking at developing pump storage, what was called synthetic pump storage using constructed reservoirs. Niagara Power Corporation, one of the senior executives came to me in 1990 and said, we've got a problem, Jim, in the Adirondacks. Sometimes when we have big ice storms and the power lines go down, the people up there freeze to death because we can't get the power in fast enough. So what have you got for an idea to help alleviate that problem? And we came back to them and said, well, we've got this idea for pump storage, and that would provide some way of storing some power up there if there was a problem, and you could use it then. They embraced the idea, accepted it, and we had an agreement with Niagara to develop the project in 1990. About 2 years later, as we were getting into it, politics changed in both at Niagara and in the state. Senior executives we were dealing with got moved on, other people came in, project died. We were very active back then with Pat Farrell and some of those folks. We put the project on hold, essentially, put it on the shelf until about 2005. 2005, I'll explain that in a second. We rejuvenated it, started over again, so it lay dormant for many, many years. The mine that we're talking about is the old Republic Steel underground mine. We're going to be going down about 2,500 feet underground. Kind of hard to conceive of how far that is underground. If you've worked in the mine, maybe you know how far it is underground. It's quite far. It's about half a mile underground, 250 stories, 9 football fields, end to end. We're about a 5-minute elevator ride. So you can imagine getting in an elevator and pushing the button and waiting 5 minutes to get to the bottom. It's a long way down. See? As I mentioned, in 2005, we restarted the project. We had a public hearing at the VFW up in Mineville to start the project. The licensing application has taken many years. You go through a series of permits with the federal government, and then you're given the permit, the right to study. You're given a permit, you're given the right to spend a lot of money. We did studies, environmental studies, various kinds of studies, and that culminated just a little while ago in submitting the final license application for Federal Energy Regulatory Commission review. This is the license application, and this is not a large one. This is actually not considered a large application. We have a project that took 10 of these. A lot of paper. We don't publish the paper anymore, and I'll explain later if you want to see some of that document, how to get it online. But it's needless to say, it's a lot of paperwork, and we study just about every aspect of the proposed project. It's not certain that there are any environmental permits required other than the license itself. It's possible we'll have one DEC application, a permit requirement, water quality permit. We're not connecting to the waterway, but there still may be a slight chance that we need a permit for that. That's usually never a big deal in hydro. And there's U.S. Environmental Protection Agency has told us that they think maybe we might need an injection well permit. We've explained to them that we're not building anything, we're not injecting anything underground. I think they understand that now, but their concern came out of the whole debate nationally as well as in Western New York about hydrofracking. I think they confused hydrofracking with hydroelectric, but we'll find that out. We don't expect there's going to be any permit required. I'm going to jump to some of the conclusions here and then go back and explain the project in a little more detail. But these are generally the questions that people are interested in, not the technical aspects of the project, but what it means to you or to the community itself. We expect about 2 years of construction, maybe 3. I'll explain a little while longer why it takes so long. It's going to be at least 100 to 200 jobs. I know we've got a lot of members of Local 1822 here tonight. This is a construction project, albeit mostly underground, but I know some of the members of 1822 have worked on tunneling and worked underground. Long-term, probably 5 to 15 jobs. Hydroelectric projects and storage projects using hydroelectric are not labor-intensive. They're really automated, but they still require maintenance jobs for repairing equipment and some other skilled type jobs. As part of second element, local benefits, real estate taxes, Tom mentioned that. What people don't realize is hydroelectric projects are generation projects under New York state law. And that's a little bit different than any other project. If you were to build a paper mill next door here, the building would be taxable, but not the equipment inside. Under New York state law, if it's a generation facility, the building is taxable and all the equipment is taxable. We're considered a utility under New York state law. So therefore, the assessment value on a generation facility is extremely high. So without doing the numbers is a significant benefit to the town and the school district because of the value of this project, which I'll explain a little later on. I should also mention generally the value is established by the state. New York State Office of Real Property Assessment assesses real property. They do it on behalf of a local assessor to help them out, but they have the expertise to appraise and value very large specialized facilities. We're also proposing to donate or dedicate a building that we'll be using during construction. The construction contractor will require a fairly large building to maintain equipment in while he's doing his work. And the plan is to then, after that work is done, it won't be needed any longer for the storage facility, hydro storage facility. It'll be donated to the town to be used as a garage to replace the one that's up there now. And size-wise, it'll be at least that large, probably larger. We've also suggested that we ask the town what other accoutrements they could use. They mentioned Lining Field rehab. The license indicates that we'll be putting up to $200,000 to do any necessary rehab or improvements for the recreational facilities. And last but not least, the area is pretty well served by water service mains in the area, but just to include any areas that are not served, there were some concerns that we disrupt anyone's wells. We don't think there's any chance of that, but the limited areas up there that are not served by wells, that are served by wells presently, we're planning on extending the town water mains along those roads, which is generally along Witherbee Road, Chipmunk Street, and Lower Silver Hill Road. The extent of the mine area is not served by municipal water now. We will make the improvements so that it can be served by municipal water. Construction will be multi-year. One of the reasons it takes so long is the mine that's up there now, the voids underground are full of water. When the operation ceased from Republic Steel in late 1970s, the pumping was turned off. Up to then, Republic Steel pumped water from the mine continually, a couple hundred gallons a minute. As a matter of fact, the town used it for their municipal water supply for many, many years. But when they shut the mine down, they turned the pumps off, and the mine slowly filled up full of water. Pat Farrell, the engineer back then, calculated down to the gallon how much water was coming in and when it would fill to the top. And he predicted that extremely accurately, within a few weeks, I think it was. And many, many years later, when the mine finally filled up and you started seeing some of that water come back out into the stream, he predicted it right on. So that one of the reasons it takes so long is it's going to take us about a year to pump the water, sufficient water out of the mine to get into certain areas to do work. The shafts, tunnels, and mine work inside will be done primarily by a large specialized contractor, mining contractor. There's several national companies that are interested in this. They would be hiring local as well, but they also bring in their own specialized people, but they generally hire extremely extensively from the local community for a lot of that underground work. It is a specialty area. A lot of people are not inclined to work underground. Having been underground many times myself, it's unique the first time you go underground, let me tell you. But once you get used to it, it's pretty common. I always tell people, whether you're 10 feet underground or 100 feet underground, it's pretty much the same. It's dark and it's quiet. Mechanical, electrical work will be performed by local contractors. Local, I mean upstate New York. That will be the type of thing where they have to go underground to do the work, but it doesn't involve mining or removing rock. See? I'm going to give you a couple of drawing overviews, and one of the things I have to mention is that the license application itself has drawings in it. It's been submitted to the federal government. We are not allowed to include those in any public documents. The government tells us that those are considered critical energy infrastructure information under Homeland Security, and hence, if you go online, I'll tell you how to go online and look at this document, you'll find a section, or actually two sections, that says you can't see the drawings. It's kind of silly in a way, because the mine drawings are actually on public file for the Bureau of Mines. But they don't want us to publicize, for obvious reasons, what could be constructed there. It's got valid reasons, but in this case, it might be a little bit silly. This is the surface, kind of a representation of the surface. The mine extends out underground here. I always describe it as like a layer cake. You've got triple layer cake, and the mine itself, where they mine the iron ore out, are the two seams of frosting in the triple layer cake. They're very thin, and the rest of it's rock. And underground, 99.99% of what's under there is still rock. There's some openings. They were large enough for men to go through and mine out the iron ore, and they've taken the frosting out of the cake. The rest of the cake is still there. We're proposing to drop some shafts down in the property of the town of Moriah. Once the shafts are down, constructing an underground power cavern that would house the equipment, and then we have another tunnel going out to bring the power lines out. I'll explain in a second what's underground here, but basically it's turbines, think of water wheels, and they operate two ways. In one mode, they pump water from a lower reservoir up a shaft to an upper reservoir, and then about 10 hours later, when we reverse the flow of water, those pumps operate as turbines. They go up backwards and they generate power. So it's a fairly simple concept. Pumps and turbines have been around for 150 years. What's unique about this one is it's pretty far underground, and the types of pumps and turbines are also kind of unique. I'll explain that in a second. So we're going to be dropping some shafts, and it sounds easy, dropping a shaft. We're dropping it a half a mile down. This is pretty common, very common in the mining industry. I've been in shafts that go down 5,000 feet in Canada. So dropping shafts is a standard practice for mining contractors. It's not a standard practice for local building contractor, but for mining contractors it is. A variety of shafts, virtually everything is underground. The only thing that'll be visible on the surface is a small entry building with hoist equipment in it, and access and some other control facilities. Everything is essentially underground. See? Again, the concept model, this is sort of another illustration. Underground we're showing here is a grid. It's like Swiss cheese. There's a lot of openings down there that are full of water and will stay full of water. A large powerhouse cavern which houses the equipment. It'll pump the water from the lower reservoir up to the upper reservoir. This is about 2,500 feet vertically. And then periodically during the day, the other part of the day, that water will come back through the pipes, through the turbines, generating electricity, and the water will come back down here. You don't wear the water out. You don't do anything with it at all. It doesn't change in temperature. You're just moving it from one elevation to the other, and that's how the energy is stored. The power will come out through a tunnel to the existing power line. There's a 115 kV line to the east of Mineville. You'll see it there if you drive by. There's a right-of-way corridor there. It's been there since way before the Republic Steel days. It was built to serve them. That does not change. We're not changing the power line. We're not running any new power lines. One of the reasons we picked this project as being a pretty ideal project is there was not the need to construct any new power lines or any new facilities. A lot of times when you have to build big power lines, it can get to be controversial. They're there already. Nothing's going to change about them. They're of sufficient size. See? This is, again, a schematic of the underground powerhouse. And the scale is kind of deceiving. This is about 150 feet long or 200 feet long and 50 feet high underground. I always like describing this. If you watch old World War II movies, you know, the submarine pens inside the mountain. There's a couple of submarines. It's like that, although there's no water here. What's unique about this project is many pump storage projects use one or two very, very, very large pump turbines. And they're generally made overseas, in Korea or Japan. They're very large, they're very expensive, and they're very timely to acquire. It takes 5 to 10 years to build them. We have a different concept here, excuse me. We're proposing to use a series of smaller units. Did that volume go up? We're proposing to use a series of smaller units in series. These are conventional pumps and turbines. They're built by a U.S. manufacturer. The pumps, the motors, and the generators are built by a U.S. manufacturer in Ohio. There's 100 of them. There's not 2 of them, there's 100 of them. One of the reasons for that is that project economics are favored by having more units. When you go to a manufacturer and you say, I want to buy 2 specialized units that only they make, they kind of price it accordingly. When you go to several manufacturers and say, I want to buy these pumps turbines, these are more or less standard kinds of units, and by the way, I want to buy 100 of them, they sharpen their pencil, and you get a pretty good price, which we have already. So that's the underground facility. There's electrical equipment as well down there that converts the power, different voltages. It's generated at 1 voltage, it's stepped up to go back out to the grid, and control equipment. During the day-to-day operation, men will be down here to do maintenance primarily, not to operate anything. It'll be operated from the surface by computer. The maintenance, however, will be an ongoing maintenance where people are down here lubricating pumps, changing things out, adjusting things, you know, as would be normal for any industrial facility. Steve? The size of this unit, this powerhouse is going to be, the size of this project is 260 megawatts. That's 260,000 kilowatts, and try to give you a scale. If that's generating power, that's enough for about 260,000 homes, 250,000 homes, which is a lot of folks. It's a big area. But this is not just generating power, it's also taking power in. During a certain time of the day, it'll take power in, store it, and then the other time of the day, we'll release that power back out. But the total back and forth is about 260 megawatts. This is considered a small project for pump storage. Most pump storage projects are 500 megawatts or 1,000 megawatts, but they're more conventional, using very large turbines. They usually blast the top of a mountain off to make the upper reservoir. They're fairly environmentally destructive. This one is different. The maximum drop is about 2,600 feet, the minimum is 1,600 feet, and we're going to be moving about 1,200 cubic feet per second back and forth. It's a lot of water, relatively speaking, I guess. Niagara Falls uses about 100,000 cubic feet per second. The Hudson River is maybe 3,000 or 4,000 cubic feet per second. Local stream around here, a smaller stream, might be 5 cubic feet per second. But that water is underground, moving back and forth through a pipe. And it holds a lot of water, 109 million cubic feet. That's about a football field, 3/4 of a mile high. Hard to envision that, it's a lot of water. But that's what it takes to actually run this facility. That water is already there. We're taking some water out to make room to get access, and then the water that's left will be used as that initial charge to run this water up and down. Because there's always slight seepage into the mine, like there was when Republic Steel operated it, we'll be continually removing about 200 gallons a minute back out to the stream as occurs today. The town has expressed some interest in maybe getting access to that water. It's very pure underground water. We have no problem with that, obviously, but that will be up to the town to go back and use groundwater rather than surface water in their municipal system. As I mentioned, there's about 100 turbines. This is just sort of specific technical stuff. Basically 100 turbines, hundreds of horsepower, big units. A turbine, just to give you sort of a mental picture, one of these turbines is about 5 feet wide and about 12 feet high. And that's the part above the floor, the part below the floor is about 12 feet as well. That's considered small for a turbine. For a pump, it's pretty large, obviously, but that's what these are. There's 100 of them. Steve? Site limitations. Really no environmental issues. We haven't found any environmental issues. There's one concern DEC had about bats, Indiana brown bats, which are an endangered species. There's no bats in this mine because it's full of water. They can't live underwater, obviously. But there are bats in the area. We are not allowed to tell you where they are because of concerns they have about them being harmed. Most of you probably know where they are. Most of the people who go into caves know where they are, and they say no more about it. We've been working with DEC, however, to make sure that the bats are not harmed even by anything we do. We are actually considered to be experts in Indiana brown bats, our company. We did a project many years ago with DEC and essentially went a long ways towards saving Indiana brown bats. If you know anything about bats today, though, the bat population has been just about decimated. About 99% of bats have been killed by white nose syndrome, and it's possible that most of these bats will not be here in 10 years, but they're trying to save them somehow. No one quite knows how yet, but what they don't want is to have any more die if they can avoid it. The capacity of this project is 260 megawatts, as I mentioned, and that's based pretty much upon the transmission lines. We've sized it to use the transmission lines. We didn't want to build any new transmission lines. There's actually more capacity available here. It probably could be a little larger project, but we've left it the way it is, leaving the transmission lines the way they are. As I mentioned, the transmission lines are owned by National Grid, and they're regulated by the New York Independent System Operator. That's the entity down near Albany that operates the electrical transmission system. They control the flow of power back and forth. They're the guys who literally keep the lights on and keep everything running in the system. Main issues. Really, the main issue on this project has been the time. Hydro takes a long time. This project has taken a long time, and it will continue to take some time. One of my things I have to do is tamp down expectations. Regulatory process is long. We've submitted the application now. FERC could take 6 months. They could take a few years. We've seen them take several years to approve applications. You never can tell with them. You never get a straight answer, or never get an answer. They go through a certain process, which is regulated by law. I'm expecting it'll take at least a year to see the final license issued. And it's not until that final license is issued that we know we have a project that's licensed that we then go to the next steps. The other issue sort of is the obvious one. As Tom mentioned, this is privately owned, will be privately owned, privately financed. So the question is, how do you get paid for doing this? What we're providing is energy storage on a big electric grid. The big electric grid is operated by the New York ISO, which is a not-for-profit entity, and we all get the benefit of them doing that. And on all of your electric bills, there's a little charge built in there, you sometimes don't see it, for what you're paying to keep the electrical grid running. You pay Niagara Mohawk or New York State Electric Gas, but a portion of that goes to running the grid, keeping it all in balance. So one of the questions are, if they need storage in order to keep everything moving smoothly and keep the lights on, and which is becoming an increasingly problem with renewable power. In the old days, all the power was generated by a big central station, big nuclear plant or a coal-fired plant, and you didn't need much storage. When you needed more power, you just cranked up the plant, the nuclear plant or the coal plant, and took care of itself. Now we have a lot of other generators on the system. We have wind, we have photovoltaic, we have people with systems on their rooftops, we have other hydros, we have landfill gas, we have all sorts of energy sources. And one of the problems that's arising is, yeah, that's great. We have photovoltaics on everybody's roof. What happens at nighttime? Where's the power going to come from? So one of the issues is becoming, well, we're going to need to store it. We're going to have a lot of photovoltaic power in the daytime, and at 5 o'clock at night, hopefully we stored some of that away to use at nighttime, otherwise we're not going to have any power. So one of the issues is who's going to provide that storage, and how is it going to be paid for? There's two schools of thought. I won't go into the details. One is it's going to be regulated, which means the utility is going to be told, get some storage and add it on everybody's bill. It'll be like a tenth of a penny on everyone's bill. The other possibility is that there's a kind of an open system for power that'll simply be market-based, that somehow people who are buying and selling power will be able to use that to store some power. The regulators are not clear. Department of Energy, Federal Department of Energy, New York State Department of Public Service have asked us to come in many times and have said, we really need storage. When are you going to build it? And we said, when are you going to decide how we're going to get paid? And you sit down with 10 of them, and 5 of them will say, build it, the market will take care of it, build it and they will come. And the other 5 say, maybe it has to be regulated. It's a national issue, it's not just here. It's coming to a head, I think. I think what's going to happen is it's going to be a mixture of both. There'll probably be some mechanism for the utilities to pay us for having some of the storage. There'll be another mechanism where some of the services can be sold directly on the system, on the computer system that operates the entire system. Schedule. We submitted the final application, this little document here, on February 13th. I think that was Friday the 13th, wasn't it? I think it was, yeah. Good luck. So that's in now. They have to review it. Earliest expected license 2016, construction 2 years later, completion a couple years after that. This is a guess. First one to admit it. We don't know how fast FERC will issue a license. People said, well, can you put political pressure on them? Yes and no. Sometimes that backfires. We've tried that. They kind of operate at their own pace. And it's not like they're sitting down there doing nothing. They have a series of rules they have to follow very extensively. They've been in operation since 1920. There's a lot of laws they have to follow, and they have to make sure that this project adheres to all those laws. So we're patient. We've taken this many years to get this far. We're going to be patient, waiting for FERC to go through the steps. Now, we've heard something back from them already. They've asked us a few minor questions, nothing major. We are expecting pretty shortly we'll get a list of additional questions they'll have. They're called AIRs, Additional Information Request. That can be anything from 1 page to 100 pages. And then we're given 2 or 3 months to answer all those. We send those back in. They read them, they think about them, and then sometimes they issue more questions. They may do that 1 or 2 times until they're satisfied they have all the questions they need, or all the answers they need to decide whether this is a go or not. Highly unlikely they would say this is not a go. It will be a go. The question is how long it will take. And the question also is what conditions they might put on it. Sometimes they'll put conditions on a project. Believe it or not, they sometimes have some silly conditions, but I don't want to make fun of FERC here at a public forum. So, but sometimes they'll put conditions on it that we have to adhere to. When you get a license in the end, it's not a license like your driver's license. It's usually about 100-page document that has lots of conditions, lots of things, lots of thou shalls, and lots of things that you have to do through the life of the project, which can be 50 years. There's things that you have to do every month, there's things that you have to do every year, there's things you have to do every 5 years. That's not unusual, that's the nature of hydroelectric projects. As I said, a couple of years to build it. Private financing, we've had no lack of interested parties wanting to help be our partners and be our friends and finance the project. The way a project like this is financed, it's a lot of money. The way these projects are financed is usually large pension funds. We'll put up the money. It's a mortgage, just like a house. They'll put up the money, you pay them back every month for 20 years, and the project has to support that payment stream, just like your income has to support your mortgage when you get a mortgage on a house. Private financing, however, no federal or state grants are expected, desired, will be applied for. We're not interested in them. They come with too many strings and it's too much of a problem. And if you build a project based upon the premise, or you plan a project based upon the premise that there's some kind of help, if that help doesn't come through, the project falls. So we don't depend upon it, we don't ask for it. If the project gets built, if it's viable financially, and we certainly believe it is, we wouldn't have spent this many years and this much money, it'll support itself, it has to support itself long term. Steve? You can follow the project. You may get bored silly following it, it's been so long. There's a FERC library, and I'll make these available for Tom to put on the town website. You can go into the FERC e-library, electronic library, and you can find the project number and click, and documents will come up. Everything from a letter they send us asking questions to a copy of this little document here. Tough reading online, but it's online in various sections. There's sections on everything from the operation to the environmental aspects to the historic aspects of the area to fish and wildlife issues, you name it, it's in here, it's all online. You can also register online and you'll be notified if there's any additional filings or if FERC does anything or issues documents to us or to the public, you'll be notified electronically when that occurs. It's all done a lot electronically now. Years ago, we used to put these together and we used to have to make like 100 copies of these and give them out to people. And everyone had one on their bookshelf, but no one ever read them. Now it's all done electronically. Steve? Questions? I'm sure it is questions. So I'll try to answer them. I'll be candid. If it's a question I can't answer, I'll tell you that. But there's going to be time to, as we go through the process, to ask additional questions. Yeah?
Yeah. I live in Whitby, and years ago when they shut the mines down in 71, it took a while for the water to start filling up the mines. And the ground shook quite a bit. What's this going to do to the ground when you start taking water out and keep flushing it back and forth?
We expect some of the shaking back then. They filled in the shafts back then, and what they did is they filled them in, as we understand it from the drawings that we have, they just dumped fill in the shafts, and then they capped them with concrete. And so what we think what happened over time is as groundwater got in that fill, it moved. basically, and dropped, and that was probably the shaking. This is an active area earthquake-wise. You probably have all felt earthquakes in this area. It's not unusual to have a tremor in this area. We don't expect, the geological studies we did, we don't expect any changes in the ground surface or anything else. This rock is very, very hard, granitic. It's nice. It's a very competent rock, probably the hardest rock you can find. It's not like a coal mine or something where you got soft things that cave in. The things that do cave in, and there's been some subsidence in the ground occasionally, you'll see it around here, is where they filled the shafts in, but they just filled them in with rock, and they didn't, you know, it settled basically is what happened. And even sometimes the surfaces they put on, the concrete surfaces, have cracked. Those things have to be repaired and then as this project is being built.
So you're saying that pushing that water back and forth will not make the ground?
We don't expect, no, that's correct. We don't expect any problems there. And we'll be monitoring it. Any project like this, we monitor during construction. We'll have seismic monitors spaced around anywhere people want them, and we'll monitor it during construction as well as after construction. And obviously, any responsibility for any problems are ours, and we'll make that clear.
Well, I've contacted the insurance company. They told me, God forbid, there was a big earthquake and my house goes down, they did pay for it.
Well, they would come after us first if we caused it.
They also explained to me that if there's a project causes the ground to shake and my house goes down, they don't pay for it.
Yeah, I'm not sure of that. I can't answer for the insurance company. What we normally do before we start a project like this, and this is not unusual, whether it's an underground project or whether it's any kind of construction project we're involving removing materials, is we'll generally look at all the houses in the area, ask people, you want us to, you know, do an inspection for you, we'll document it, take pictures, give you copies of those so you have them, you know, see what's there, make sure there's no problems, and then if something develops, we've got evidence that it was something that we did. But no one wants to shirk the responsibility. Yeah. Yes?
Yes, you know, I understand the water level within the mine is very close to ground surface at this current time. And I'm just trying to understand, when you remove water from the lower mine and you want to lift it up and store it at a higher elevation, where is that water going to go?
Best way to explain is the mine filled up over the years, and when it got up to, it's all rock, it's all solid rock down there, so it filled up. When it got near the surface, the top surface is not solid rock, it's soil and gravels and things. So when it got up near that soil, it started percolating through that soil into the streams. And so you can actually go up here on, which tributary is that, Steve? Tributary 5? Steve? What tributary is that where the water comes out?
Sorry?
The tributary, what tributary is that where the water comes out?
CA 6-5.
CA 6-5, it's a tributary to the brook there. And it actually comes out there through a pipe, so it's full. So the water, the mine is sort of overflowing into the creek now, so into the brook. So that water will be taken out. Now we've created a void in the mine, in the underground mine. So that water is going to be moved up and down into that void, but it won't hit the surface again, is the best way of putting it.
Okay, so the water is never going to rise up to the level that it is now?
That's correct.
It'll always be lower?
That's correct.
I see.
Yes?
If you're standing on the surface, what are the old mines? Which one are you closest to?
The mines we're utilizing are again, Steve, correct me if I'm wrong here, the two mines that we're using, which are really on top of each other, are the Old Bed. Remember, Steve? The Old Bed and Harmony. There's a series of mines there, yeah, as everyone
What about
knows.
the 21 mine? Is that involved?
The Joker Pit was at the upper end of that. That will not be involved, but the Joker Pit is connected into that. And some of the other mines are connected way, way deep through small galleries. Those will be plugged. So there's a mine, the New Bed will not be affected by this. That's up to one side. There's a very small connection between the two mines, but that will be sealed. As well as the mines up in near the shock incarceration, Fisher Hill. That mine actually indirectly connects to the mines down here, but through very small openings. They're probably plugged now, but we'll be plugging them if they're not. Yep.
So you're going to seal off the big open pit up there?
Yes, we expect to be sealing. That's open to the mine down below. We'll be sealing that mostly just to prevent bats from going in, because we don't want bats in the mine. But that's expected to be sealed. The pit will still be there. It's a big pit. Yes?
somehow affect the groundwater? That-
We don't expect,
Down four, like 400 feet, where we get our water from, you know, the real well.
yes.
And I want to know, I mean, if you're moving water, or when will that, is there a possibility for?
We don't expect any possibility. The well, 400 feet deep, is essentially in the gravel area that's on top. And that area gets its water from rainfall, naturally. The
No,
water,
it's sort of solid rock all around.
well, at some point, if it's in solid rock, it's getting its water from the gravels on top. The water we're talking about is much deeper than that. We do not expect any problems whatsoever. We are, I'm not sure where you live, but we are going to, just as a,
Around it, well, you're talking about the Chipmunk Road. We're not on Chipmunk Road, but we're on
okay,
the extension over towards Crawford Pond Road.
okay.
On that side.
I think that's outside of the mine area.
And actually Chipmunk Road came out of there.
Okay. If it's in the area of the mine, we're planning on putting public water in that area just to make safe that we're not going to affect anything. If it's outside the mine area, in any event, it'd be too far away. So we'd have to actually see where you are, actually, locate you. I don't expect problems. If there is a problem, we're going to provide the public water to make sure there's not a problem. Yes?
There's a shaft that's very close to where you want to build your maintenance building by the town property. It's the Don B shaft. It goes down at an angle. Do you envision using that for
No.
No?
No, our access, we decided a long time ago that using the existing shafts was impractical and dangerous and had a lot of other issues. So our new construction, as it were, is off to one side of the mine. It's not actually within the mine area. It's down through rock where there's no ore. Once we have that created in that shaft and that cavern, we're then going to tap into the mine from the side, basically. Now, having said that, the shafts that were sealed back in the late 70s, early 80s, Don B shaft being one of them, a lot of them have collapsed or there's problems with them, if you can see it from the surface. We do expect that those are going to have to be fixed. They've got to be sealed more permanently. They've been there 40 years and they don't last forever, so there's going to have to be resealing of those shafts. And there's about 20 of them. You see the large ones, Don B, but there were a lot of smaller ones where they didn't put concrete caps on them or anything. They just put material in them. And it stayed there, but eventually it slid down. So that's why most of you know, you careful when you're walking around, you can have a surprise. Yes?
You mentioned earlier that I guess the amount of power that this is actually generating and storing can supply up to about 250,000 homes. Is Moriah and the surrounding areas, are we benefiting from that, or is it being sold off to other areas?
It has to, this type of facility in our company cannot sell retail to local customers. The National Grid, Niagara Mohawk, and New York State have the franchise. You must buy your power from them. This will go into the wholesale market, basically. Indirectly, everyone will benefit, but there's no way we can affect the local rates or the relationship with the power company. Commonly asked question, I pay the same rate. I own generating facilities, and I'm a Niagara Mohawk customer at home.
Right.
And when my wife gets the bill every month, she's complaining, and I say, hey, can't do anything about it. Yes?
So it's a $250 million project.
Yeah.
Is there federal investment tax credits involved, energy tax credits?
No. Right now, there are no energy tax credits for this type of facility. Any normal tax credit that you might get for making a capital investment might be available, but this project doesn't initially make a lot of money to take advantage of that. I say there's no federal.
How about the investors? Do they take advantage of it?
We don't expect this is going to be privately syndicated. We expect this is going to be financed solely through like a pension fund debt rather than through any kind of syndication of tax benefits. Tax benefits can be, our experience is we don't use them. We've never used them. They can be fleeting. So if you plan on a project that uses tax benefits and they change the law, which they do, it can crater the project or it can cause problems as you're going through. So we don't count on those.
Is there any NYSERDA rebates involved?
No.
Is the project itself, if it generates 250,000 households, how much of the project, the $250 million is going back directly into the local economy?
Well, I don't want to estimate the tax benefit, but I can tell you the project would be assessed approximately for its construction value, $260 million. The
Local assessment would be
local assessment, local taxing authority would see this project on the tax rolls being equal to approximately $260 million. You can check the total assessment locally. Say Town of Moriah is about a similar number. So a significant effect on the taxes. I don't want to predict the actual numbers, it's way premature, but it would be a significant portion of the taxable base in the town as well as in the school district.
And of the project itself, $250 million, on the construction phase, of how much of that is the contribution to the local, directly to the local community?
Yeah, contributions are the garage, the water mains, the improvements on the recreation, couple $1 million, several $1 million.
So it's less than 1%?
Yes. Yeah.
And there's no way to equivocate the generation of electricity to reduce costs for National Grid for the local community?
No, no legal way, because that's a wholesale project. Yeah. The primary benefit of the community is tax base, long term. Yes?
But your shaft sinking process, is that going to be with your mechanical mining that probably would be bored?
It may be. There will be several shafts. The initial shaft we expect will be sunk conventionally. They still use mechanical means, but it'll be sunk conventionally. The secondary and the south level shafts will be done with raise bores. And that's a technique where once you're down at the bottom and you want to do another shaft, you move sideways, they drill a hole from the surface, and then they pull a cutter head up from the bottom and they sort of cut the shaft from the bottom up. So it's mechanized. Mining today is pretty heavily mechanized. In the old days, it was, much more a manual operation.
And the shaft construction, then your level or burden will be stockpile, like filling pile?
Well, yeah, the issue, we have about a quarter of a million cubic yards of rubble, or waste spoil that'll be disposed of. Some of that will go in the Joker pit to seal off that opening. Probably the majority will go in the Joker pit to seal that opening off. Nowhere near the amount of spoil that is already there from the piles. We're not going to add to the piles, I guess is the best question. We're going to find a place for it, and it's either going to be underground and additional storage is down there, or in the Joker pit. Yes, back there?
I actually have two questions. My first one is the power being generated, as I understand it, for the wholesale market, so it's not being like funneled straight to New York City.
No.
Second question, my husband's is dealing with the turbines. The turbines for the efficiency, are you using as much energy to power the turbines to pump the water back up as you generate and go back down?
Yes, I understand the question. Yeah, it's an inefficient system. In other words, if we take 1 kilowatt hour to pump it up, we only get 0.8 of a kilowatt hour back. So we're not creating energy. We're using energy to run the system. There's no, it's an inefficient, I say inefficient, it's about a 70% efficient process. We lose energy in the process. But that's acceptable because otherwise there's no way of storing energy. So it's the price you pay for taking power in the daytime and having it at night, or conversely taking it at nighttime, which is what they used to do, and using it during the day. So it's just the way the electric grid is working now, the problems they're running into, and they're going to have more problems, is maintaining that balance of generation when you need it. So storage is going to be a necessity. So it's not a perfect efficiency. If it was, it would be perpetual motion, and I would be very wealthy and wouldn't be standing here.
I just want to say, you're
Yeah.
really generating power. You're not, it's just the turbines themselves during the day that are pumping the water up. That's still power that's being generated. You're not storing electricity. It goes into the grid directly after you produce it, does it not?
Well, you're storing water, you're not storing electricity. What you're doing is you're taking electricity, we're getting it from the grid, we're buying it as it were, we're running a pump and pumping it up. We've used electricity at that point, but we've taken the water from a lower level and put it at a higher level. So now it has the ability, when we let it run back down, to make the energy back. Doesn't make it all back, but make most of it back. So we're storing the electricity, as it were, by storing water, okay, by moving it from one level to another. It's very difficult to store electricity other than batteries is one way. It's very inefficient, very expensive, and you can imagine the number of batteries it would take to do something like this. There's a lot of talk about doing big batteries, but they're 10 times the expense of doing it this way. And any system that's been built for years has always been pumped storage, and probably will be.
It's a very effective project. My last question is, would the company be prepared to provide 2% of their total budget towards infrastructure improvements in the community itself?
I don't know, that's really an open question. I think when you see the tax ramifications as the project comes, forward, I think the benefits there will far outweigh any other benefits we could give. And it's a question of what the overall economics are. Yes?
How much water, when you take the water out and then it goes back in, how much is it gonna be in there? Like, is it gonna be the same height or half after when you put it back in?
We take it from a lower level, about 2,000 feet underground, 3,000 feet underground, and we move it to an upper level, which is about 1,000 feet underground. So if you think of it, Matt?
You know how you said it was gonna take a year to drain it out?
Mhm.
And then when you put it back in, is it gonna be lower than the height it's at when it starts?
Yes, it will be lower, yes. If you think of the mine having this much water, we're gonna take out about the top third or half that's filled up over the last 40 years, and then we're gonna be using the remaining portion, moving it up and down. So we are taking a large amount out initially. It will keep coming back in. No matter what we do, it keeps raining, streams keep running, water keeps percolating down through the ground. So we will continually be taking out about 200 gallons a minute, pumping that back to the stream or to the town if they want to use it for municipal water. And that's just the natural part of the process. And that's what Republic Steel did for decades, is they always had to take water out of the mine, otherwise it would have gradually filled up.
Yeah, I have some springs in my yard that over time they got bigger and bigger, so I'm hoping maybe they'll dry out.
There's a benefit. Yes.
What's the possibility of taking and having two reservoirs so that when you let the water go from one down through the turbines, you could use the electricity, some of the electricity that you produced, to pump up water up into another reservoir for the next day so that you could just keep swapping reservoirs?
Well, we're sort of doing that, except one at a time. You can't create energy where it doesn't exist. There's no such thing as perpetual motion. Well, we're essentially doing that. We're taking it from the one, and then 8 hours later, bringing it back up. It's just doing this.
But it's going to cost you money to pump it back up.
Yes.
If you pump it up while you're producing your own electricity, it wouldn't cost you anything.
Then that's electricity, if we're using it for pumping back up, that we can't sell back onto the system.
Well, it's a question. I think that'd be cheaper than having to buy it.
No. It just simply is the matter of how the economics work when we're doing it. If we're using electricity for doing our pumping, we can't use it to sell on the market, and that's what we're trying to sell, is the storage of electricity on the market. So it's got to net out essentially to zero. You can't make it more than one. It's going to be actually less than one.
Is there a premium value to producing electricity at night?
It's funny, it's changed over time. Historically, pump storage operated by using power at nighttime from big plants, nuclear plants generally, or coal-fired plants, what else were they going to do in the middle of the night? No one was using power. They didn't want to turn them off, so they would use that power, which was very low cost. 2 o'clock in the morning, power rates are very rock bottom. And they would use that power, pump it up, and then in the daytime, especially peak hours in the morning or in the evening, at 5 o'clock, get that value back. Buy low, sell high. That is changing over time rather dramatically. So now what's happening is almost the opposite. In California, they have more electricity than they know what to do with in the afternoon because of all the photovoltaic systems. And now energy prices at 3 in the afternoon in California are lower than they used to be at 2 in the night. But at 7 o'clock at night or 6 o'clock at night in California, when the sun goes down, the power rates are skyrocketing. So it's an evolving mechanism. When we started this project, it was started as a conventional project, off to peak power at nighttime, solid back in the daytime. It's flipped around, which is probably what's going to make the economics really make sense, because that's the way the future is going. power from photovoltaic is getting cheaper than anything else right now. Yeah. Yes, back here.
There's 200 gallons a second or whatever that goes out through the creek, and right now that's filtered through topsoil. What's gonna happen if you're just dumping it out on the surface? Is that water dangerous in some way? I know there's an awful lot of cancer in town.
Yeah. It's, the natural groundwater in the mine has been tested over the years. It's extremely pure water. It's naturally occurring, filtering down, as you said, in the mine itself. When the mine pumped it out over the years, it was tested. The facility at Fisher Hill uses that water presently for their supply. It's tested daily. We've tested it. The only thing unusual the water has in it is more iron than you would like. It's like a well that has a lot of iron in it. So if someone were to use it for municipal water, the iron's going to have to be reduced. But there's no other chemicals that we've been able to find in it, nothing unusual. There was nothing left underground. There were stories years ago that they left some things underground. That's not true. We have all the documents, so we don't expect it. As far as additional cancers in the area, I mean, I don't know. I can't tell you what could be causing those. Yes, over here.
This is not a question, it's just a comment. Assuming that all the questions are going to be answered to the community's understanding and acceptance, I want to say thank you for the investment. I think this is an area that could desperately use a $264 million project. And as a representative of the construction industry, I certainly welcome a project like this that's going to last 2 years, because the local community could use that kind of work around here. So on behalf of my local, I'd like to say thank you for making the investment, and I hope it all goes smoothly with FERC, and we can get it started as soon as possible.
And if it doesn't, we're going to take you and your truck down to Washington. Thank you.
I just know we'll go with you.
Okay, let me take a couple of more questions over here.
How are you gonna get the power from your turbine to the station?
Tunnel. We're going to be 2,500 feet underground. There's a tunnel being taken all the way up to where that transmission line is on the other side, and that's where the cabling will come up. It'll come up underneath those transmission lines and we'll connect in there.
You're gonna tunnel or it's already there?
No, we're going to tunnel, yeah. There is actually a small tunnel that goes over in that area that the mine used years ago for a exploratory drift, but this one has to be an incline. It has to eventually reach the surface over underneath the power line. So it'll be there. Yes?
How does your meter know when it's peak rate?
The way the system works, the independent system operator, this big not-for-profit entity down near Albany, has a building twice the size of this building with gigantic computers in it, and they monitor the power at all times, and they actually establish the power rate every 5 minutes in New York State. Every 5 minutes the power value changes, and it changes in each area. We're in the capital area here, and that rate 5 minutes from now will change. It's like a auctioning process, basically. So it changes in real time, all the time. They also...
They use an algorithm?
Yes, it's all computerized. It's basically based upon...
If I'm not home, I'll be charged for a maximum rate.
Sometimes you are, it depends on the utility. Most of you have a standard rate on your power bill, but it will change every month. Sometimes in some areas you can get a time of day rate. The rate will actually change depending on what time of the day is. Depends if you're New York, if you're NIMO, or if you're NYSEG. But most people have a standard rate, but you'll notice on your power bill, the supply portion changes every month. And if you remember a year ago last January, when the power rates skyrocketed, I mean, they were 4 cents, they went up to 20 cents, and everybody got that shock a month later in their power bill. That's how the system works now. The old days, it was all regulated, kind of smoothed out, and then in 10, 15 years ago, the idea across the country and across the world, really, was to unregulate the system, and maybe that would bring economies to it. You know, it's like when they used to regulate airplane fares. Everybody had the same airplane fare. Now prices are all over the place. Is it better or worse? You tell me. A lot of people say it might have been better 20 years ago. At least you knew what the rates were going to be, but they're not going back. It's a system that changes. Yeah. We got one over here. Yeah.
I have a question regarding your FERC application. You had mentioned the facts and your consultation with PEC. Has there been any?
Yes, absolutely, a lot.
Are those consultations done within the application?
Yes. Yeah, with the exception of one thing, the discussions with DEC and Fish and Wildlife on the bats they've asked that they be considered confidential. That information is not in the public document, it's in the document that FERC has, because Fish and Wildlife and DEC does not want certain information about the bats out in the public. They don't want people to know where the critters are because they're afraid people will disturb them. But those discussions have been going on for some years now, fairly simple discussions actually. That's all documented in the application. You'll see part of it, sort of the summary, but the detailed stuff is considered privileged information. FERC has it, the agencies have it, but other people can't have it according to the law.
Do you envision those consultations involving requests for additional study?
I don't expect so, no. Yeah, I don't want to say never, you never can tell with FERC, but we don't expect so. We think we've answered and addressed all the issues. As I mentioned, our company did the landmark study, the pioneering study of Indiana brown bats back in the 80s. The agencies know that. We've proposed to make sure certain protections are in place and then to go beyond that and to help them save bats that aren't even near the mine, gone above and beyond. And as we stay here today, we think that's been resolved. But you never say never with FERC or with the agencies. Yes, again.
Yes, sir, I'm not trying to get into a debate. It's for my own reassurance. This project is going to have center shaft with the water being transferred from the ground through the reverse process of the electrical turbine to pump it to the higher level, correct?
That's right.
So, in the gentleman's statement about having two upper reservoirs, you'd have to have twice as many shafts and twice as many pump generators to supply two upper lifts.
Yeah.
You can't make power while you're pumping the water up.
Right.
Because the turbine can only turn one way.
Right, it's going one or the other, yeah. Well, we have an upper reservoir and a lower reservoir, it's just that they're not on the surface. They're part of the underground structure is the best way of putting it.
You're still taking the water from the lower one through the turbine, pumping it off to the upper one, and then storing it there, and then stopping the pumping process, dumping the water back down the shaft to make the turbine produce
Right, that's right.
energy.
Right,
So you couldn't have two upper levels unless you had two shafts.
right. One advantage of this underground facility, a lot of pump storage that are done in other places, they have upper and lower reservoirs. In the wintertime, they get ice in them, and that causes a problem. This one's got an advantage in that we aren't expecting any ice problems. Not that you don't have ice up here.
Not 1,000 people.
Not 1,000 people on the ground, right? Yeah, we take another question way back there. You, yeah.
I know when they built the bridge, I never actually met a whole lot of local guys that worked on it. How many local jobs, or how many guys in the area do you think will be able to get employed building this thing?
Yeah, I think more than probably the bridge, but this is not a public bid. This will be privately bid. We don't have to adhere to any particular laws as far as the bidding process goes. These are specialty contractors. The mining company will be a large mining company. There's no large mining companies in New York State in this area, so it'll be for someone from the western part of the country or Canada, but they generally will hire locally when they find qualified people to do it. Now, there will be certain specialties that they will not be able to find, apparently, possibly local people, but I think most things they will. A lot of it depends upon the willingness of people to work in mines. It's not for everybody. Some people fit into it very easily. Other people want nothing to do with it, just because you're underground.
So would they bring, like, say, 80% of their workforce or more? Or could you
I wouldn't be guessing, but I would guess at least that. I mean, I think it's certainly the mechanical, electrical, because of the size of the job is small enough, that would be all local contractors. The mining itself will be an outside contractor, but they don't generally bring in 200 people from, Montana. It isn't economical. They will bring in core groups of people, and they will, find people locally. Now, the mine here has been closed for many years, so there's not skilled people who previously worked in the mine. So they don't have that resource. On the other hand, the types of things they do today are much more mechanized, so that people who can operate equipment and do various things, as long as they can be trained and want to work underground, I wouldn't expect any issues there. And we will certainly encourage them to hire locally. I mean, makes no sense to truck people in. Yeah.
My question is in regard to your FERC application. Early on in your presentation, you mentioned there were a few points that were unknowns, one of those being mineral rights.
Yes.
And I'm curious, does Albany Engineering, do they recognize mineral rights as property rights that need to be acquired?
Oh, absolutely. Well, required is a question. We recognize mineral rights. To the extent that we extract some minerals as part of this process, whoever owns those minerals, they're theirs. We're not taking them. And if whoever owns those minerals say to us, you're taking some ore out of the ground and we want that ore, you're more than welcome to have it. We don't claim any interest in extracting minerals from the ground. Absolutely not.
Just one follow-up question. Have you already conducted a title search?
We've started title searching years ago, enough to know that it's very extensive in this area with the mineral rights and deeds that have been filed. We know those mineral rights are out there. We know they've been separated from the other real property rights. We know the two major parties we think hold either the mineral rights or the surface land or the shafts and voids, and that's, I presume your company, K. Stafford's involvement, who bought those rights, and or Solvay, which we understand owns certain surface, owns the voids, we believe, I think they believe, owns the tailing piles. The issues that we have, and the questions are legal questions that still have to be resolved. Okay, is there a line between the two? And we don't fully understand that ourselves, nor do our attorneys. We'll be exploring that as we're going through this. The license will issue. We understand that any rights have to be acquired. The license does give us the responsibility for acquiring them, but also the ability to acquire them. But we're not trying to take something that's not ours. We own no real property rights up here now. We will own solely a license when we start, and hopefully an agreement with the town to use certain of their property, and then beyond that, any additional rights have to be acquired. Some of the issues that we're dealing with is who owns the hole in the ground with the water in it. And does someone own that? And if they own it, is that their responsibility to seal the shafts up and to maintain the integrity? There's some tricky issues there. Yeah. Yes?
To date, how much money has your company had?
Since 1990, I'd hate to guess.
That's a lot of money.
Yeah, I mean, we're a small company, to be honest with you. We're a very small company. We put this one on the shelf back to 2005, and we work on it along with other things that we're doing. We have a lot of other development projects, so it isn't like we got 10 people on it day and night for 2 years or for 5 years. But it's in excess of 7 figures easily. I don't want to know. Yes.
Okay, we have the two open pits, one on the Powerhouse Road and one on Right Avenue. And I was wondering how or if, when you're putting in those shafts that you're going down under, that's going to affect any of those in any way.
We don't think those pits are connected to the mine underground at this point. We think that they were excavated for other reasons. Time will show whether that's correct or not as we do more detailed studies and more surveys. Those are not part of the property we're expecting to be involved in. If someone has those pits and has a concern, or if they want them filled, I'm sure we can accommodate them. We presume they're not being used for anything right now, but we don't expect they're being used. Most of our operation is going to be 2,000 to 3,000 feet underground. Yes. Yep. I can show you next.
Okay. First one is, you said that for power generation, you're using a series of turbines, and once again, pumping up. Would you use the same number of turbines to pump up as you do generating on the downflow?
Good question. And that's one of the reasons we have these sort of the 5 turbines in a row. And let's see if I can explain this. It's kind of hard to understand. You need all 5 when you're pumping the highest amount of water, but when you're generating, as the water comes down, you actually don't use all 5, you use 4. And it has to do with keeping the best efficiency. So it's sort of like having 2-wheel drive and 4-wheel drive. There's times when we need 4-wheel drive, there's times when 2-wheel drive will suffice, and that's how we maintain the efficiency. So that's the unique configuration you see is 5 turbines in a row, and then 20 sets of those has to do with trying to maintain the peak efficiency so that each pump or turbine is running at its peak point all the time. Think of it as sort of, you drive a stick shift, downshifting, always trying to stay in the right gear and trying to maintain efficiency. Yeah.
Okay, and the second question is, do you see in the future after this project is up and running for a while, do you see an opportunity for expansion, like another similar project?
Good question.
Or as a model for maybe other idle mines in the country elsewhere?
We've looked at other mines for other people as well as ourselves. There's some out there. This one's pretty unique because it's very good rock. It's very deep. It's got a transmission line. It's probably the best one we've seen in a long time. There's some others in the area. They're not as large. We looked at Fisher Hill at one point, and it's nowhere near the size of this one, capacity. We've looked at mines in the western part of the state. They're gypsum mines, which is a very soft material. You run water in it, it's going to dissolve. Same with salt mines. So maybe, but limited, not our interest. We've got more than enough to do to get this one going. As far as expansion, it's possible, but again, you know, one at a time. I'm not getting any younger. Yes?
How many hours in a normal daily cycle would you be pumping up, and does it take the same amount of time to come back down?
No, because of the efficiency loss, historically, if you pump up for 14, you generate for 10. That's the sort of the rule of thumb. That's all changing, however, with the way energy is working now with photovoltaic. It's conceivable that we would be, you know, pumping at 2 o'clock to 4 o'clock in the afternoon, and then generating from 5 to 7, and then maybe power coming from another source, pumping at night. It's possible that the power may come from different sources, maybe photovoltaic, could be wind, it could be nuclear even, or it could be other sources. We see this as sort of a bank. We expect the way this is going to operate is we're going to be operating a bank, and someone is going to contract with us to store a certain amount of energy on a weekly, monthly, daily basis, whatever they want. And we see it kind of in that mechanism.
How long in hours would it take to completely pump up?
It takes about 14 hours. Yeah. Any other questions? Maybe one more back there?
Is there going to be any kind of periodic noise or periodic damage?
We don't expect any, no. It's underground, no noise from operating, generating equipment or anything. No. We don't expect any seismic problems. There are seismic issues in this area. This is a very active area, and we don't expect that we're going to be adding to that, no. It's a very solid rock here, and one of the advantages of this mine is it's granite. Granitic gneiss is what it's called. It's extremely hard, it's extremely competent. Up near the surface, it's gravels and things. We're talking a half a mile under. It's very tough rock. Yeah.
How many kilowatts do you think it'll produce, and how much power or how many kilowatts will it take to pump the water back up?
Well, the ratio is roughly 14 to 10. So the total energy that it produces in a given year, don't quote me on this number, is probably a 500 million kilowatt hours, something like that, 500 million kilowatt hours. But it takes power to put it in. So we're not creating energy here. We're not making new energy. We're just moving it from one time to the other. Yeah.
How are you dealing with the heat rejection from the motors?
Good question. Big opportunity here for someone to use the waste heat. There's a lot of extra heat coming off this, and that'll be coming to the surface. We've thought about how we're going to use that heat. There's some good ideas. We've looked at capturing it for generation. We've also talked about capturing it for other things.
Heated swimming pool.
You want a lot of heated swimming pools, greenhouses, that kind of thing. That's sort of pie in the sky. That'll come in time.
So you're not rejecting into the water?
No, absolutely not. No.
How about a geothermal system for future highway garage?
Well, actually, I think the heat from this could very easily heat the garage. The waste heat coming up the shafts will easily heat the garage. Yeah. Anything else?
All right, well, I want to thank Jim. I've learned a lot here this evening. There's been some excellent questions. You know, as we're all aware, we've waited a long time, but I believe it's going to happen. The man certainly knows what he's doing here, seems to, anyway. The benefits, I heard some talks about benefits for the community and so on. Obviously, the tax base will be, the increase in your taxable value will be substantial. Not to mention what it'll do to some of the special districts that are out there where this project's going to be located. I mean, it'll be significant. I've also had conversations, we need a lot of infrastructure improvements. We need to replace a water main that, from Grover Hills down to Moriah Central School. That's projected to cost, $4 to $6 million. We've got some major wastewater issues in the hamlet of Witherbee, and we have had some discussions on some of those areas, and I can certainly say that the community and the school district is going to benefit. I think it's a great partnership. I think it'll be, if this project happens, I'll say when this project happens, it's going to be a rebirth for this community. I mean, the irony of it is, this is a community that when Republic Steel pulled out, about 60% of our tax base went along with it. And now those same mines, where all that tax base was lost and all that surface when they tore it down, is going to come back in a different format, but still somehow relates to those mines. So, yes. It won't have any impact in the village because it's located outside the village of Port Henry. So all of that taxable value will be outside the village. So, but we could change that. All right, well,
come on here, Tom.
Go ahead. Again, I want to thank everyone for coming. We will try to keep the website updated. Any question that you have, you can call me and I can get a hold of Jim.